Hello, today I will teach you how to draw a Lewis diagram. For our first example, I will show you how to write N2 or nitrogen gas. Before we can start the Lewis diagram, we should determine how many electrons are going to be in our Lewis diagram. If we pull out a periodic table, we can see that there should be 5 different electrons for each nitrogen atom. We can determine this by looking at each column. This should have 1 electron, 2 electron, 3, 4, 5, 6, and 7. Nitrogen lands on the 5th column, therefore there will be 10, because if we go 2 times 5, because there are 2 different nitrogens, that will equal 10 electrons. Now we can write our Lewis diagram. We should draw the 2 ends and 5 electrons around each. Now we must create bonds around that will intertwine both ends. So these 2 can be a bond, these 2 can be a bond, these 2 can be a bond, and look at this. 1, 2, 3, 4, 5 for each different N atom. That is ideal. We cannot leave it like this though, we need to vesperize it. These 2 can be lone pairs, these 2 can be lone pairs. That means there are 2 electrons that will be grouped together in our Lewis structure. So we can write it as N, the 3 different bonds that we determined up here, and then the 2 different lone pairs. As you can see, the bonds and the lone pairs are on complete opposite sides, and this is a linear molecule. And that is, for the next example, we will draw H2O, or water. Now, let's do the same thing that we did last time. Let's pull out a periodic table and look how many electrons we have to start out with. We have two H's, which will have 1 electron. So 2 times 1. And we will have 1 oxygen, which will be 1, 2, 3, 4, 5, 6 electrons. Now if we add them up, we should have an end result of 8 electrons. Now we can write out our Lewis diagram. We should write the O in the middle of the 2 H's to provide symmetry for our molecule. Let's draw out 1 and 1 because there's only 1 electron for each of the hydrogens. And let's draw 6 dots around the O because there are 6 electrons for every oxygen. Now let's connect some of the dots to make bonds. Now we have ran out of H's, and we can make and now we can vesperize our molecule. These 2 should be a lone pair, and these 2 should be a lone pair. Now we cannot finish our Lewis diagram like this. These bonds still have electrons in them, and they still are repelled by these lone pairs. Therefore, our final Lewis diagram should be as such for water. Finally, we will use NH4+, a polyatomic ion. Pull out the periodic table. We have 1 N, and that's 1, 2, 3, 4, 5 electrons. 4 hydrogens, so it's 4 times. Add them together, it's 9. Because of this plus, we're going to take away an electron, so it's -1. That would be 8 electrons in our final Lewis structure. If we're going to draw this Lewis structure, we should draw the N with 4 H's around it. Each one has 1 electron, and the N has 5. So 1, 2, 3, 4, 5. So we can connect these and see how we're left with just 1. We're going to take that away because of the plus. So then we will have H, H. And to indicate that it's a polyatomic ion, we need to put it in brackets and have whatever charge it is. In this case, it's going to be plus. And that is it.